Yeah, welcome back to Aliphatic Teaches. Today we are going to be looking at organic chemistry in chemistry class. What is organic chemistry? Organic chemistry can be defined as a chemistry of carbon atoms. That is, we want to study the carbon atom. Out of all the elements in the periodic table, carbon is unique. And one of the reasons why carbon is unique is its ability to catenate, what refers to as catenation. Catenation can be defined as a property of the carbon atom to join end to end in order to form a straight chain, a branched chain, or a cyclic organic compound. Let's for an instance, when we have carbon atoms this way, this is a straight chain carbon atom, which we call butane. Likewise, carbon can also join end to end to form a branched chain. This is another compound which is formed from this previous compound, which is butane. And this one is 2-methyl propane. So this compound is called a branched chain. Likewise, we can also have a cyclic compound. So one of the major properties of carbon atom that make it to be unique is catenation. So that can make it to form a long chain compound, a branched chain compound, and as well a cyclic chain compound. Now, let us now look at the terms in organic chemistry. So the first term we look at is electronic configuration of the carbon atom. Now, electronic configuration of carbon atom. Since we know that carbon has an atomic number of 6, when we write the electronic configuration, we have 1s2, 2s2, 2p2, 2 plus 2, 4, 4 plus 2, 6. Now, in this case, what do we mean by this? Is that as this carbon is, the outermost shell here, we have 2s and 2p, meaning that carbon belongs to period 2 and group 4. That is 2 plus 2 give us 4. So we can use this to determine our period and group of any element in the periodic table. Let's say, for instance, we have sodium with atomic number of 11, that is 1s2, 2s2, 2p6, and 3s1. 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 6 is 11. The outermost shell here is 3s1. So this 3 means period, while this one is the group. So when you check your periodic table, you will actually see that sodium belongs to period 3 and group 1. Now, but when we have the same period here, this carbon belongs to period 2 and group 4. 2 plus 2 give us what? Give us 4. Now, if you understand this, we can now see that these 2 electrons that is in the outermost shell, meaning that anytime a carbon atom wants to form a compound, 4 bonds must surround that carbon atom. The carbon atom must be surrounded by what? By 4 bonds. Look at this. We have carbon this way. So the first bond, the second one, the third one, and the fourth one. So 4 bonds must surround it because it has 4 electrons in the outermost shell. So this is the electronic configuration of carbon atom. The second thing we are going to look at is hybridization of carbon atom. Hybridization of carbon atom in organic compounds. What's the hybridization? Hybridization can be defined as the concept of mixing orbitals in order to form a new type of hybridized orbital. When we are mixing an orbitals together, two or more orbitals together to form a new orbital, a new hybridized orbital, we are referring to as the hybridization. Now, we have four orbitals, which are the s, p, d, and f orbitals. S, P, D, and F orbitals. So, the s, p, d, and f orbitals. Now, in organic compound, we have different families in organic chemistry, which we call homologous series. We are going to be looking at each of the family. We look at each of the family to now look at the hybridization of each carbon. Now, there's some family in organic chemistry that are bound together by single bonds. There's some family, they have double bonds. There's some family, they have triple bonds. Now, let's go by looking at them one after the other. The first one we consider is alkane. Alkane has the general molecular formula of CnH2n plus 2. So, and the first member of alkane, we normally call it methane. We are still coming to that naming of organic compound. If I put 1 in this n, when my n is 1, it's going to become C1, H, 2 times 1 give us 2, plus 2, 4. That is CH4. Now, following this compound, I have this carbon as the center element. Then, 4 hydrogen is surrounding it. Hydrogen, another hydrogen, the third one, and the fourth one. Now, I don't want to calculate. I want to know the hybridization of this carbon, the center carbon. And don't forget, this carbon is surrounded by single bonds. So I have ground state, my ground state element. So from this, if you could recall from our electronic configuration of carbon that give us 1s2, 2s2, and 2p2. So here I'm going to have 1s2, that's 2 electron will enter, then 2s2, 2px, 2py, 2pz. From our elementary chemistry, you will recall that this s must not contain more than 2 electrons. This p, 6, this d, 10, and 14. 2, 6, 10, 14 electrons that must enter. Now, since 2 electrons must enter this place, it means the face of the bus is just 1. And since 6 electrons must enter this p, and each of these s is containing 2, meaning it's going to be divided into 3. That is 2 electrons, 2 electrons, 2 electrons, making what? 6 electrons. Now, at the excited state, we have 1s, 2s, 2px, 2py, 2pz. Now, let us now feed this electron. For the ground state, we have 1s2. 2 electrons enter into it. 2s2. Then 2p2. When we get to pdf orbital, pdf, they are called degenerate orbitals. Meaning that according to Hund's rule of maximum multiplicity states that in a degenerate orbitals, electron must fill the orbital singly before pairing. Meaning electron will enter this p orbital singly. So we are left with these 2 electrons. So 1 electron will enter here, another electron will enter here. Now, at the excited state, this 1s2 will be repeated, but they are ground states. 2s2 will be repeated. Now, 2ps, 2py, 2pz, then 1 electron enter this, another electron enter this. So at the excited state, we now consider this structure, which is a methane. The name is called methane. How many hydrogen is surrounding this methane? We have 4 hydrogens, meaning 4 electron is coming to enter this excited state. 1 electron, the second one, then third, and the fourth. Now, the 1s and 2s orbital, 1s and 2s orbital, they have the same energy level. We call them s. Then this is p orbital. How many bonds do we have in this p orbital? We have 1, 2, 3. 3 here. So which means the hybridization of this carbon here is sp3. So any carbon atom that is surrounded by a single bond, that carbon atom will be having sp3 hybridized. So this carbon atom is sp3 hybridized. The next one we are going to consider is alkene as the next homologous series. Alkene has general molecular formula of CnH2n. So the first member of alkene is 18. It used to start from carbon 2. So it doesn't have 1 as a first member. So this is 18. And if you write this 18, this is the structure of 18. So you want to now know what is the hybridization of this carbon here or this one. So we can only consider one. Either we consider this part or we consider this part. They are still the same. Let us consider this part. When you consider this part, this carbon atom has 2 hydrogens. Now, ground states. Our ground states, consider this carbon, 1s2, so 2 electrons will enter, 2s2, the next 2 electrons, then 2p2. When it gets to p orbital, pdf, they are called degenerate orbital. So electron will enter them singly before pairing. So we have the first electron, the second electron. Now, at the excited states, similar thing will occur. It will occur. Now we now go on to consider this. How many hydrogens surrounding this carbon? We have 2 hydrogens. So one hydrogen enter this place, and the other hydrogen enter this. So now we want to know the hybridization of this carbon atom. Both 1s and 2s, they are of the same energy level, that is S. Then we have P. So how many bonds do they form in this P? We have 1 and 2, that is 2. So which means this carbon here is sp2 hybridized. This carbon here is sp2 hybridized. So this is the way to get the hybridization of carbon atom in 18. So any compound that are bounded together by double bonds, their hybridization is always sp2. Now the third one we consider is alkyne. This is another homologous series with the general molecular formula of CnH2n minus 2. And the first member is always with carbon 2. That is what is called ethyne. Ethyne. So when we put 2 here and put 2 here, C2, 2 times 2 give us 4. 4 minus 2, we have 2, C2H2. So we have the formula here. Now, by considering this one at the ground state, 1s2, 2 electrons enter, 2 electrons. Then when you get to p orbital, 2p2, these 2 electrons will go singly. Now, at the excited state, we have 2 electrons as well. 2 electrons, then singly. Now, we're now back to this compound. You either consider this left one or the right one. If you consider the right one, we have 1 hydrogen. Consider the left one, we still have 1 hydrogen. It means 1 hydrogen is coming into this p orbital. So when we have it, we are going to have 1 hydrogen here. Now, what is the hybridization of this? The 1s and 2s, they are of the same energy level. That is S. Then we have P. Then how many bonds do we have in P? We have just have only 1 bond pair here. That is sp1. So when we rewrite it, we have sp. So which means this carbon atom here is sp hybridized. This one also is sp hybridized. So anytime we are given a compound, we must know is if the carbon is surrounded by single bonds, the hybridization is sp3. If it is surrounded by double bond, is sp2. If it is triple bond, is sp. Let us consider this compound. Now, let us consider this compound. We should not forget that a carbon atom must be surrounded by 4 bonds. Let's look at this carbon. 1, 2, 3, 4. Complete. 1, 2, 3, 4. This one is complete. 1, 2, 3, 4 is complete. It's okay. Now, what is the hybridization of this carbon here? This carbon here, because it's surrounded by single bonds all around, is sp3. When you look at this carbon and this carbon, we have double bond here and a single bond here. So this double bond supersedes the single bond. So this carbon here is sp2. Why this one also is sp2? Because double bond is joining them together. So when you are given a compound, you know if a single bond is surrounding the compound, it is sp3 hybridized. If we have a double bond in the other carbon, it is sp2. If it is triple bond, it is sp hybridized. So if you find values in this aliphatic teaches channel, kindly subscribe to my channel and do not forget to turn on your notification bell for my subsequent contents.